Welcome to Maths and Science by IITian channel. In this lecture, which is useful for IIT JEE, Mains Advanced and also NEET for physics subject in rigid body motion, which we are dealing at present, the chapter of rigid body motion or rotational motion. In this, let us get the insights of angular momentum. Angular momentum, we all know that L is equal to, L is angular momentum, it is represented by letter L, it is a vector. L is equal to R cross P, where R is a radius vector, P is momentum, linear momentum. Angular momentum L is equal to R cross P. In this lecture, deviating from this regular L is equal to R cross P, we will be defining what will be the value of L, the angular momentum, in terms of moment of inertia and angular velocity. L is equal to I omega, where angular velocity is a vector, angular momentum is a vector, where I is a matrix, that is moment of inertia tensor. The main focus of the lecture will be on building the moment of inertia tensor and calculating the angular momentum. This is the main focus of the lecture. How to develop? Moment of inertia, we all know I is equal to mr square. Depending upon the axis of rotation and axis under consideration, we have Ix, Iy, Iz. In a three-dimensional, we have 9 parameters of moment of inertia: Ixx, Ixy, Ixz, and Iyx, Iyy, and Iyz, Izx, Izy, and Izz. If these 9 parameters are what they mean, how they can be represented in a matrix form or a tensor form, and when the tensor of I is known, what will be the matrix form of omega? Omega is equal to column vector omega x, omega y, omega z. For column vector and row vectors, you please refer to my matrices lectures which are available from this channel, Maths and Science by IITian. Let us dwell into the proof of this L is equal to I omega, and let us try to develop a numerical on this, so that if any problem comes, first understand the concept, then develop the numerical and solve it. This whole process takes about 2 lectures. In this lecture, we will develop the concept. In the next lecture, following lecture, we will solve a numerical at JEE Advanced, NEET and JEE Mains level. Numerical will be solved next lecture. In this lecture, we will be going for developing this lecture. We will develop concepts to prove that L is equal to I omega. This is what we are going to prove now. We already know this solution. We already know L is equal to R cross P. P is nothing but M omega cross R. For this also please refer to my earlier lectures. This is also a very important derivation. These two. Then the value of P we will put in back in L. What happens? Let us see. L is equal to R cross M times omega cross R. Because V is equal to omega cross R and P is equal to M times V, where V is the velocity. These things we have already dealt in the previous lectures. Then with this, what happens? This is equal to M into M, will take it out, R cross omega cross R. Do you agree? Now, it is a vector triple product. What is the value of a vector triple product? I have already discussed in the vectors. Please refer to those lectures if you have any doubt. Vector triple product A cross B cross C is equal to B times A dot C minus C times A cross B. This is dealt in very much detail in my previous lectures on vectors. Now, what happens to L? L is equal to M times R cross omega cross R. That becomes omega times A dot C means R dot R minus R times C times A dot B. A is R, B is omega, R omega, R dot omega. Do you agree? Then it becomes R dot R is equal to R square, because it's a scalar quantity. This becomes M into omega times R square times omega, rather we will let us write like that, not omega times R. It is R square, scalar should come first, and omega minus R times R dot omega. Like this it is simplified. Then it can also be simplified as in component form, ith component. Let us say in component form we can write L is equal to, we can write in the component form, that is some ith component let us say summation of m will be mi, the mass of the ith component, into ri square omega minus ri into ri dot omega. Here mi is the mass of the ith particle, ri is the position vector, ri square is nothing but square root of xi square plus yi square plus zi square. I is the moment of inertia. Can we replace this particular value somewhere with moment of inertia? Let us try to do. Mi ri square is nothing but I. Then shall we go for some x direction? Any direction, let us try to do. Lx is equal to sigma I mi into ri square. Because omega is a vector, it will have components wx minus ri is a vector, hence it has got a component rx. That is in the x direction. What is the component? xi. Because r is equal to ri is equal to square root of xi square plus yi square plus zi square, which you already know from the vectors. Then xi into when you expand this xi omega x plus ri I am expanding as xi, yi and zi. Yi omega y plus zi omega z. This is what is the value of Lx. Now similarly Ly, Lz and Lx. L is equal to, we know, L is equal to, we have to prove I into omega. L is equal to. If you see mi ri square or mi xi square, that's all going to lead to I. So that we will find out Ixx. Ixx is defined sigma mi into y square yi square plus zi square. You just see in the direction of xx, the component will be, r component will be square root of y square plus zi square. Mixi square is nothing but mi yi square plus zi square. Then in direction of yy, it will be sigma mi xi square plus yi square. In the direction of zz, it will be sigma mi, it is zi square, it is not xi yi square, it is zi square. It is xi square plus yi square. Then what is the value of ixy? Ixy due to symmetry is equal to iyx, that is equal to minus sigma mi xi yi. Similarly, ixz is equal to izx is equal to minus sigma mi xi zi. These things are from vector algebra. I have already explained about the vectors in the previous classes. If you have any doubt, please refer to the previous lectures. Yz is equal to izy is equal to minus sigma mi yi zi. These are all cyclic, don't worry, cyclic values. These are also cyclic values. So that if you remember one, if you understand, not remember rather, if you understand one, these are all cyclic values, they repeat. Now we have got all the values. From these values we will develop, next step, develop a matrix, symmetric matrix. That symmetric matrix is called as the matrix tensor. That is the moment of inertia tensor. Moment of inertia tensor. This particular matrix. Why it is ixx here, iyy in diagonal, it will be izz. And when you go this way, ixy, ixz. If you go this way, it will be ixy, or we can say iyx. Both are same. And iyz. If you go this way, it will be izx, izy, and izz. Very simple. Very simple. Because we are proving it, it's taking little more time. But in the examination, no proofs are asked in this JEE examination. They will give the question, they want the answer. Now, the moment of inertia tensor is like this. We know the values of ixx, we know the values of iyy, ixy, this, from this. Ixx is sigma mi yi square plus zi square, iyy is equal to sigma mi xi square plus zi square, izz is equal to sigma mi xi square plus yi square, and ixy is equal to iyx is equal to minus sigma mi xi yi. Ixz is equal to izx is equal to minus sigma mi xi zi. Iyz is equal to Izy is equal to minus sigma mi yi zi. Once you know these values and you have developed the mi tensor, it is developed from L is equal to Rp. It is not developed separately from somewhere. From L is equal to Rp, we have got this. This one we got from L is equal to Rp. Hence, L is equal to I omega. This is proved now. Where provided where I is this I tensor, moment of inertia tensor is this one, and omega is, that means ultimately what we have got is L is equal, sorry, we will take black pen, L is equal to Ixx, Ixy, Ixz, Iyx, Iyy, Iyz, Izx, Izy, Izz into the vector omega, column vector, omega x, omega y and omega z. This is the value of angular momentum. This is the value of the angular momentum. If either you will be given in the questions will be tricky, they will not be as straight as this. It is from this L is equal to I omega. Questions will be tricky. In the questions, what they do, they will say that tensor is given to you, tensor will be given to you. Once moment of inertia tensor is known to you, it will be asked to find out the moment of inertia about a particular axis. Please try to understand. Moment of inertia about a particular axis. They never mention about the angular momentum. From this concept only we have to take out the things and we have to find out the moment of inertia about a particular axis. Now, I will give one question. This is the concept behind it. Now, I will give a question to you. You please try to solve it. I will be solving that question in the next lecture. Try to solve it. A practical question given in the one of the examinations. It is given that question is moment of inertia tensor. Tensor means don't be afraid to know about the tensor. Tensor is nothing but a matrix. A symmetric matrix. You see Ixy and Iyx both are same. It is a symmetric matrix. Please try to understand. It's a simple symmetric matrix. A simple symmetric matrix is given as like this: 1, 3, 4, 3, -3, -5. This question is developed by me after looking at one of the questions in a competitive examination. 4, -5 and 7. This is the moment of inertia tensor. Find moment of inertia about the axis passing through (1 by 2, √3 by 2 and 0). There is an axis passing through this point. This is the moment of inertia tensor of the rigid body. Tensor is given, and it was told that it is we have to find out moment of inertia about an axis passing through this point, because moment of inertia is found out about an axis. IXX means axis, XX axis. IYY means YY axis. Moment of inertia is found out about an axis, and that axis is passing through this point. Then find out the moment of inertia. Are you able to follow? Moment of inertia is given. Question is like this. Try to understand. Question is moment of inertia tensor is given. They have not given moment of inertia values. Moment of inertia tensor is given. It was asked to find out moment of inertia about an axis passing through a point. This is the question. It looks simple and it looks familiar, but for doing this we require the concept. We have developed the sufficient concept, and we have related this moment of inertia tensor to angular momentum, and because this angular momentum moment of inertia tensor combination, which is usually, if people are unfamiliar, please remember this: L is equal to I omega. Usually people remember L is equal to Rp. From L is equal to Rp, R cross P, we got this value, L is equal to I omega, where I is the moment of inertia. And some questions, they may ask you to find out the angular momentum, and tensor is given and omega is given. Second type of questions can be, this is one type. Second type can be, moment of inertia tensor is given, omega column vector is given, required to find angular momentum. In that case, multiply those two matrices, omega vector is a column column matrix, tensor is a matrix, multiply them, you will get the matrix for angular momentum. Are you able to understand? You just see how we have derived everything. This is the most important formula. L is equal to Ixx, Ixy, Ixz, Iyx, Iyy, Iyz, Izx, Izy, Izn, Z into omega x, omega y, omega z. This is the column vector. So that you will get Lxx, Lx, Ly, Lz. L is nothing but, it is a column vector Lx, Ly, Lz. If you want to, if you have to write L is equal to Lx into I plus Ly into J plus Lz into K. Omega is omega x into I plus omega y into J plus omega z into K. These type of problems do come. If a tensor is given, you have to find out. If a tensor is given, we may have to find out angular momentum, we may have to find out the, if angular momentum is given and tensor is given, then we have to find out, means we have to find out the inverse of the tensor, then we will find out the angular velocity. That question can also come. Third type of question, I will write in the next page. Another type of question can be angular velocity vector is given, vector is to be found out, angular momentum is given in vector form, is given, moment of inertia tensor is given. Then take the inverse of the moment of inertia tensor and multiply with the angular momentum vector and find out the angular velocity vector. That's all. Angular velocity vector omega is equal to I inverse. This is moment of inertia tensor inverse into L bar. L bar is equal to I omega. Please remember this. And these are the different types of problems that you come across in rigid body motion. Now, in the next class, once I solve one numerical, you will understand about this tensor and finding this angular momentum and finding the angular velocity in a rigid body motion, and how to find out the moment of inertia once tensor is given, to find out the moment of inertia about an axis which is passing through a point. If there is a, with this I want to conclude this lecture. If there is a value addition to your knowledge, please share my videos, subscribe to my channel, Maths and Science by IITian, and if you have any doubts on this particular lecture, please comment. I will reply to your comments. Best of luck to everybody, and thank you for seeing my lecture and my video. Please subscribe to my channel. Thank you. Best of luck.